Let's introduce cosine. So cosine is another trig function. It's two out of the three functions we're going to be going over, and it's a very important function as well as sine. So in the previous video, we determined sine of an angle, so sine of theta, is equal to the opposite side over the hypotenuse. Well, cosine is a bit different. Cosine of theta is equal to the adjacent side of the triangle over the hypotenuse. So cosine also has its own little abbreviation. It's COS here. I like to say cos just to help me remember things. So let me make this a bit smoother here. So we know sine of theta is equal to opposite over hypotenuse, SOH. And I want you guys to take mental note of this too. Cosine of theta is equal to adjacent over H. And also take note of this. And you'll see that in the next video. But let's focus on cosine. So cosine's a bit different. So if we take a right triangle here, let me push this down here. So if we take a right triangle, and let's say we want to get the cosine of this angle. Well, if this was side X, this is side Z, and this is side H, hypotenuse. Well, we know that the cosine of this angle here, theta, so we're going to say theta, just for this example, is equal to the adjacent over hypotenuse. Well, first of all, how do we determine the adjacent side? Well, to determine the adjacent side, there's a few ways you can do this. You could say it's the side that's closest to the angle that you're getting the cosine of, that isn't the hypotenuse. Or there's a more reasonable explanation here. It does take a bit of remembering. It is a bit lengthy and complicated, or it can seem that way. But it's important to note that when you take the cosine of an acute angle, so you take the cosine of an angle, two sides of that triangle are going to make up that angle. They're going to come together to make that angle. And it's always going to be the hypotenuse. That was a horrible square. It's always going to be the hypotenuse and another side of the triangle that make up that acute angle. So we know that side X here and the hypotenuse, side H, make up this angle. They are put together to make this angle. So when you get the cosine of an angle, it always involves the hypotenuse and the other side that makes up this angle. Unless you're getting the cosine of the 90-degree angle, but you most definitely don't do that. You could, but it's not really reasonable. You don't typically do that because the adjacent could be Z or X. There's no opposite because the opposite side would be the hypotenuse, so you can't get the sine, but the cosine could be either Z or H. So there's two adjacents, and it's typically, I believe, 0. In fact, I actually think it's just 1. Let me figure this out. Yeah, the cosine of 90 is 0. I remember correctly. So in this case, the adjacent side is X, so adjacent over H, hypotenuse. So X over H is the cosine of this angle. And that's a little visualization here. Now let's work with real numbers here. Let's work with solid numbers and whatnot. So let's take our triangle again. And now let's switch it up and let's go for this top angle here. So we're going to say that's angle A. This is going to be the hypotenuse. This is going to be side X. In fact, I'm not going to say side X. Let's do an actual number here. Let's do a 4, a 3, and a 5. If anybody remembers, this is a Pythagorean triplet because 3, 4, and 5 satisfy the Pythagorean theorem. Okay, and we know this is a 90-degree angle and this is a mysterious angle. We don't know that angle. So let's say angle A is equal to 47, right? Angle A is equal to 47. So if we were to get the cosine of angle A, which is the same thing as saying the cosine of 47, since we know that angle A is 47, this is equal to the adjacent over the hypotenuse. We know that the hypotenuse is 5, so we can put that in the denominator. And the adjacent must be 4, because side 5 and side 4 make up the angle, but side 5 is the hypotenuse, so that means 4 must be the adjacent side. So the cosine of angle A, which is equal to the cosine of 45, is equal to 4 over 5. Now I'm about to show you guys something a bit interesting about cosine and sine together. So let's take another angle, or another triangle here. And if we were to say this is angle A, and this is angle B, the sine of angle A, is always going to be equal to the cosine of 90 minus angle A. And this is a bit simpler, but what this means is, let's say if A was 30 and this was 60, and this is actually true, the sine of 30 is going to be equal to the cosine of 90 minus 30. Should probably rewrite that here. 90 minus 30. Well, why 90? Why isn't it 180? Because, all three angles add up to 180. Well, the reason it's 90 is because you typically don't get the sine or cosine of this 90-degree angle. And when you get the sine or cosine, you're involving these two acute angles of the triangle. And we know that these two acute angles must add up to 90 degrees because they're complementary. And this is 90 degrees, so this is 90 degrees. These two must add up to 90 degrees to satisfy the fact that all three angles must add up to 180 degrees. So we always use 90 minus 30. So in this case, sine of 30 is equal to cosine of 60. And it's always going to be just the opposite angle of this angle. So the sine of an angle is going to be equal to the cosine of the opposite acute angle to it. So like the sine of 47 is going to be equal to the cosine of 43, because in this case, if this side here wasn't 30 and this was 47, right? This side wasn't 60 and this would be 43, because these two are complementary. 47 plus 43 is indeed equal to 90 degrees. Before we end, I want to just tell you that there's a few things that you got to remember here, and you'll understand this part here. So remember, the cosine of an angle is equal to the adjacent side over the hypotenuse. And remember that the sine of an angle is equal to the opposite side over the hypotenuse. And also remember that this would be CAH, cosine, adjacent, hypotenuse, and this would be SOH, sine, opposite, hypotenuse. And that is the introduction to the trigonometric function cosine.